Everyone, Mrs. Jones here. In this video, we are going to talk about proportions. Perhaps you've already seen proportions and worked with proportions, but if not, have no fear. We're going to do a quick recap right now. In case you don't remember, or if you've never seen proportions before, proportions is an equation stating that two fractions are equal. Or in other words, we have two equivalent fractions. Whoops, can't write and talk at the same time. Two fractions, here we go, are equal. Or in other words, we have two equivalent fractions that are set equal to each other. So this here is an example of a proportion. We have two fractions that are equal to each other. However, we need to solve for x. And there's lots of relationships going on here, but probably the first and the easiest one to see is the relationship between 3 and 15. I know that in order to go from 3 to 15, I multiply by 5, or in order to go the other way, from 15 to 3, I divide by 5. So if I'm trying to solve for x, I want to think about this green relationship, and I'm going to divide the 10 by 5 as well. And so that's going to tell me that x equals 2. If I then think about these as fractions, and I say 2/3 equals 10/15, that is true. I have two fractions that are set equal to each other, and I know that they are equivalent. So here's an example of another one. Again, we can right now think about the relationship between 3 to 9, and I know I would multiply by 3, or I could go the other way and know that 9 divided by 3 gets me to 3. And so I want to think about this blue relationship and divide in order to get to x, and I would see that x equals 7. Another way of thinking about this is I know that 9 and 21 are both divisible by 3. And so I know that 3 goes into 9 3 times, and 3 goes into 21 7 times. And so you can see my purple automatically becomes the equivalent fraction that I was looking for over here. But what happens when it's not as simple like this? There isn't an easy relationship to see between the 22 and the 15, the 22 and the 7, right? It's not easily identifiable. So we have to figure out what to do in this situation. And so here's what we do. I want you to think about how you might fill this in. All right, here's what you're going to do. If you see a fraction equals a fraction, then you're going to do something called cross multiply. So here's what I mean by that. There's actually a really cool, let's go back to the first example we had of 2/3 equals 10 over 15. There's a really cool relationship that also exists in proportions, and that's when you cross multiply. And what I mean by that is I take my diagonals and I multiply them. 3 times 10 equals 30. And if I go and I multiply the other diagonal, 2 times 15 also equals 30. So your diagonals in a proportion are equal. And so this becomes really important when you're trying to solve proportions that don't have an easily identifiable relationship. So if we think about this one, we are going to apply our cross multiplication. So I always circle my diagonals like this to help me. I'm first going to do my 5 times x, which I can write as 5x. Next, I'm going to do 2 times 8. If you want to just skip that step and rewrite it as 5x equals 16, that's okay too. Now, this right here is an equation that you know how to solve. You're going to divide by 5 on both sides, and our final answer is going to be x equals 16 fifths. All right, on this one, I'd like you to pause the video and see what you can do and then come back. All right, you're back. Hopefully you thought about your diagonals and multiplied. So when I do that, I have 2w, and I skip to knowing that 9 times 7 equals 63. Then I'm going to divide by 2 on both sides to isolate w, and so your answer should be 63 over 2, or 63 halves. Okay, now for the last type of example. What happens if it gets a little trickier and we have an expression, as we see here, involved within the proportion? Well, here's where the distributive property comes in. Again, I'm going to think about multiplying my diagonals, but here I'm doing 2 times this entire unit on the bottom. So the way that I can write that is 2 parentheses 2x minus 4. I am doubling, or I'm multiplying by 2 this entire thing that was on the bottom. Then I know equals my other diagonal, 3 times 7 is 21. Again, you know how to do this. I'm going to distribute. So I'll have 4x minus 8 equals 21. We'll add 8 to both sides. And so we're at 4x equals 29. My last step is to divide by 4. And so x equals 29 fourths. All right, last one. I want you to pause the video and try this one on your own. All right, you're back. So hopefully you thought about your diagonals here. So in this situation, we're going to do 7 times that entire thing of 3 minus 5w, sorry, and then 2 times 3, which gets me to 6. You're going to do the distributive property, which will get you to 21 minus 35w, because right here you'll see we're distributing. I'm going to subtract 21 on both sides, so I'll be at negative 35w equals negative 15. I'm going to divide by negative 35 on both sides, and my last step is to simplify my fraction, so I'll end up with 3/7. So hopefully this makes sense, and hopefully you're feeling good about cross multiplication. If you have any questions, don't hesitate to ask, and we'll see you in class.